सर स्टार्ट कधी करायचं मला सांगा.
शंतनू
येस सर.
शंतनू
येस सर. येस सर.
शंतनू
आवाज येतोय सर.
हा ते सर स्लाइड सरांची पुढे जात नाही, बघ बर काय होतं.
सर नाही, माझ्या समोर तरी सरांनी फक्त फर्स्ट स्लाइडच ओपन करून ठेवली आहे. आय गेस ते रेडी आहेत म्हणून. सर कन्फर्म करू शकता का तुम्ही?
एक फर्स्ट स्लाइड दिसते, पुढे मुवमेंट होत नाहीये.
केली होती सर त्यांनी, आता त्यांनी फक्त रेडी करून ठेवलंय त्यांचं, असं आहे इफ आय एम नॉट रॉंग.
पुढची स्लाइड मूव्ह होत नाहीये.
सर तुमच्या प्रेझेंटेशन पॉवर पॉइंट मध्ये चेक करा एकदा, नाही तर स्क्रीनशॉट स्टॉप करून परत स्टार्ट करा.
एक मिनिट चेक करतो.
खालीच आहे ना.
हॅलो, स्लाइड दिसते का आता?
येस सर, स्लाइड दिसते.
मूव्ह होते
सर तुम्ही अजून केली नाही आय गेस. हा, होती आता.
आहे ना?
अच्छा.
ओके, थोडा लॅग आहे का आता? दुसरी स्लाइड दिसते?
हो हो.
ओके, दिसते.
हो सर. येस.
ओके ओके ओके.
नांगरे सर
सर
सुरू करायचं का? नांगरे सर
एचओडी सर नाही आले ना अजून आय गेस.
एचओडी सर आता नांगरे सर येस म्हणले करूया सुरुवात आपण.
शंतनू,
येस सर.
आवारी सरला फोन कर ना.
सर वेदांतला सांगा ना प्लीज.
वेदांत,
सर मी
एकदा सरांना कॉल कर ना.
हो सर.
खडकर सर, 1-2 मिनिट वाट बघू.
2 मिनिट वाट बघूया, मग सुरू करूया.
आणि नांगरे सर कुठे? नांगरे सर नाही दिसत आहे.
नांगरे सर आवाज येत. नांगरे सर
आलेत सर, ते आलेत.
नाही, जॉईन झालेत, आवाज येत नाही.
त्यांचा आवाज येत नाही नांगरे सरांचा.
माईक ऑन आहे त्यांचा.
हो नाही, थांबा फोन करतो.
कराय सर.
यस.
सर एक स्टार्टला फक्त 2 मिनिटं स्क्रीन शेअर ऑफ करू शकता का तुम्ही? लाईक लेट मी इंट्रोड्यूस, त्याच्यानंतर आपण स्टार्ट करू.
ओके, एक मिनिट. झाले का ऑफ?
नाही दिसते
नाही
अजून.
झाले.
वेदांत,
हा सर.
झालं बोलणं सरांचं?
हो, 2 मिनिटं सर. जॉईन झालेत सर, आवारी सर आलेत. हो.
वाडकर सर
वेदांत काय झालं? फोन झाला का सरांशी?
आले सर, जॉईन झालेत. आवारी सर चालू करू देत का?
हॅलो,
हा
सर सुरू करू का सर?
सरांचं चालू.
हा चला वेदांत, शंतनू सुरू कर.
येस सर. येस. Right. Okay. So, good morning and welcome to all the honorary members of Indian Waterworks Association, principal and the faculties of AISSMS College of Engineering, today's experts and the participants present for the two-day national level faculty development program on recent trends in water resources and environmental engineering, organized by Department of Civil Engineering, AISSMS College of Engineering, in association with Indian Waterworks Association Pune Center. After yesterday's three wonderful sessions, today we have three more sessions, namely the advancements oxidation in wastewater engineering, advances in the water resource engineering, and the advances in environmental engineering. So let's move to the first session of the today. That is session 4 of the entire program. I would like to welcome Dr. R.S. Karare, Professor and the Head of the Department Civil Engineering at Bhivrabai Sawant College of Engineering, Nare, located in Pune. Let's go through a short brief about Karare sir. He has pursued in Bachelor of Engineering in 1999 in Walchand College of Engineering, Sangli, Shivaji University. Masters in Environmental Engineering in the year 2001 from the Walchand College of Engineering, Sangli. He has received his PhD in Civil Engineering in 2015 from NIT Surat on the topic Pentin and photophenol oxidation of selected pharmaceutical components buried in derivatives in water. He has 16 years of approved teaching experience and the 2 years of industry experience. He has worked as a reviewer of International Journal Applied Water Science. He has contributed as an expert in civil engineering postgraduate conference organized by ICOER and BOS Civil Engineering on 11th and 12th of June 2018. He has published more than 10 research papers at the national and international level. So, it's a great honor for us to have you here on this day. Now, I would like to invite Dr. R.S. Karai sir for the session. Participants are requested to put their questions and doubts in the chat box. The feedback link for the session will be provided at the end of session. Over to you, sir.
Okay, good morning, all of you. Am I audible?
Yes, sir.
Please check.
Yes,
Okay. Okay. So, thank you. Let's begin with the session. So, today I have selected about the advanced oxidation processes. Since water and wastewater treatment are need of the hour, but in the current scenario, because of various emergent contaminants which are being detected in the water bodies, and as a result through unauthorized or maybe partly treated various constituents, various emergent contaminants, various contaminants of personal care products, they may be of pharmaceutical origin, or they may be some industrial constituents which have been detected. And so the proper treatment of this water and wastewater to protect the environment is very essential. Now, there are various conventional treatment technologies which everybody is well aware of here. So I'm not going in detail with those conventional treatment technologies which have been practiced since so many years. So just I want to throw some light about what made this uh, topic. Main focus, the scope of my presentation will be basically concerned with these emergent contaminants. So these emergent contaminants, though the name suggests that these are something new, but these have been detected in recent years, and their effects have been felt, to be more precise, I should say, because there are many pharmaceutical drugs have been reported in even groundwater, surface water, and wastewater. So it's very important because the water which is used for various purposes, and various surveys and studies have shown that their presence, even though the concentration may be very less, which is beyond the detection limit, Now that is the other part. We are not going in more detail with the equipments how to detect, but that research is also equally important. And it may also happen that a particular sample of wastewater after collection, uh, if it is tested through some advanced technology, may detect its presence in small concentration, but that doesn't mean that the concentration is very low. The effect of those compounds, even though it is detected in a small concentration, has to be considered. And we never know that how they are changing our life, how they are affecting the entire uh, environment. Uh, so of special attention has been given towards such compounds about their removal in this topic. And since uh, the living standard, we always talk about the living standard because of change in the living standards of the people, mm, the sewage quality has been changed. Many personal care products have been detected, and the conventional treatment technologies um, may not be sufficient to completely remove these compounds. We check the BOD, we check the COD, we focus on the BOD, COD values during the treatment. But in addition to that, the compounds which contribute towards the COD, we measure the COD, we have the prescribed limit, and accordingly we decide about the how the wastewater is to be discharged. There are different effluent standards which everybody is well aware of. But the compound, the toxicity of the compound, and the associated effect of the compound is to be studied, and care has to be taken that how we can remove these compounds so that the future effect on the environment can be controlled, because there are very severe effects. Some of the studies have shown that many what you can say about the birth control pills or the hormone therapies which have been used have shown various impacts on the aquatic species also, and ultimately it comes to the human health. So the Environment Protection Agency has rated these compounds as a carcinogenic and hazardous compounds. And most of these pharmaceutical compounds, uh, why I am talking about these PPC is because uh, these have not been separately, uh, what you can say, given as uh, a permissible limit like the other compounds. These have been, we generally measure the COD value. So a pharmaceutical compound or other pyridine based compound or the personal care compound will contribute to the COD value, and we are measuring the COD value of the sample, and we are focusing on the COD value. So what my target is to convince you is that we should focus on the compound more, and we should devise such methods which will target the compound. So when the compound is totally destroyed, then ultimately the other effects will be minimized. So these are the some of the studies which I got it from some literature. Uh, there are many, because since India is moving towards the uh, most of the use of these drugs and manufacturing, and recently last more than say 8 months, we all know about this pandemic, COVID-19 pandemic, where most of the drugs have been practiced. So in the future also, we never know how these drugs will be dealt with, and most of the people are switching towards the safer side. So we try to consume the drugs so that we can at least safeguard ourselves. But from environmental engineering point of view, we need to study about the fate of these compounds, because whenever a drug is prescribed to a patient and when the patient injects the drugs, uh, we never know about how the metabolism takes place about the drug. As an engineer, I'm saying, medical experts may be knowing in detail about these things. Uh, so most of the drugs are not completely metabolized in our body system. Some are partly metabolized, and as a result, they are excreted out. So in the urine and feces, the traces of these drugs have been detected, and they will enter into the sewerage system, where it will go to the sewage treatment plants. And if the sewage treatment plants are not designed to deal with such compounds, then such traces of compounds, pharmaceutical compounds, will bypass the sewerage system, and they will end up in the water bodies, which are a source of drinking. And again, that source of water bodies, when it goes to the water treatment plant, the water treatment plant is not sufficient to deal with these compounds. Most of the sewerage systems and water treatment plants deal with the conventional technologies. And if at that location where such traces are found, if the treatment is not efficient, then that may end to the consumer tap. So these traces of drugs will end up to the consumer tap, where the people may consume the water thinking that it is safe, but it may contain such compounds, though in less concentration, but in coming years, coming decades, they may show their effect on the future generations. So that is what about the background which I want to talk about the fate of these pharmaceutical compounds. And overall class is called as these PPCPs, that is pharmaceutical and personal care products. So there are thousands of compounds which can be studied separately or as a mixture, and each has its own effect. So it's very difficult. Lot of research can be done about such class of compounds. This is I have taken it from a source where they have shown the different sources of these drugs. The personal care products, you can see the animals use these drugs. So even the excretion by these urban pets may also contain these drugs. Aquaculture operations, to the farms, to the industrial pollution treatment, and the drugs which are used by the people. Most of the drugs are also discarded. Even after the expiry of the drug, it may happen that some may directly dump them. So that may be unwanted disposal, illegal disposal directly, and that will directly enter into the sewerage system, which may create further problems. Even many OTC, that is the over-the-counter drugs, they are never consumed, and they may undoubtedly dispose down to the toilets and may enter into the sewerage system. And ultimately, the sewerage system drugs may are detected in the water bodies. So in fact, our water bodies are not natural water bodies, no longer remain. A water body running through a city no longer remain as a natural water body, but it may be called as a medicine pool. So more focus about some advanced treatment technologies has to be given. One of the Swedish research team they have taken some samples, and it has shown that the concentration of the pharmaceutical drugs detected in the water body was very close to a wastewater treatment plant concentration, very high. And if has to be certain advanced treatment method which should remove pharmaceutical pollution is measured in India. So we have to take this as a precautionary step to save the future population, and more research about the different types of treatment technologies which will deal with, with such pollutants which are ultimately carcinogenic in nature is necessary. Likewise, there are different, so some of the selected studies I am showing here. Sky is the limit for this because uh, if mainly the focus was about the Indian findings, and most important thing which I want to tell here is many microbes, because the current treatment focus on the biological processes, and many microbes are getting resistant to these drugs. We always say about, we always or listen from the, or something comes about some medical person talking about this antibiotic resistance, and usually they say that don't directly prefer some antibiotics, take a prescribed drug. So such things are necessary, because if we consume such antibiotics, antibiotic resistance even develops in the human body. Same thing happens to the microbes which are present in the water and wastewater. So if such drugs are detected in the water bodies or wastewater bodies, the microbes which are present there will develop a resistance. And tomorrow, even our biological treatment units may fail to function properly. Now, most of these sewage treatment plants are functioning using these biological treatment processes because they are more economical. But these biological processes, as we know, they deal with only these biodegradable, because certain non-biodegradable components are difficult and it may take more time. But if these microbes turn out to be antibiotic resistant, then we fear that the biological treatment may not alone be sufficient. We have to go for some supplementary chemical treatment methods, or a combination of biological and chemical treatment methods. Even research findings have shown that these human cells, they fail to grow normally in the laboratory when exposed to trace concentrations of certain pharmaceuticals. So medical research is very active related to their role, but as an environmental role, we have to take help of their research in finding a suitable treatment technology to cope up with these emergent contaminants. So this report, one of the report on these pharmaceuticals in drinking water, published by the World Health Organization, says there is a statement, they have given a statement, there is a need for further research on potential human health risk that could result from long-term exposure to trace levels of pharmaceuticals or a combination of pharmaceuticals in potable water. So, what are the issues related to this treatment of APCPs, pharmaceutical and personal care products? So, they are currently not regulated in the drinking water directives. Drinking water, we focus about the other parameters. So, there is a need that these PPCPs should be included in these drinking water directives because there are traces of these PPCPs detected in the drinking water. The wastewater which contains these PPCBs, pharmaceutical and personal care products, that is the short form for it. It's mostly alkaline. It depends upon the type of the drug and it cannot be treated biologically. So that is the concern. Biological treatment fails to treat these emergent contaminants. And daily thousands of these pharmaceutical pollutants are entering into the wastewater. And that's why the wastewater day by day is changing. It's not the same wastewater which may remain in its characteristics for a longer time. The quality of wastewater 5 years before, the quality of wastewater today, and the quality of wastewater 5 years down the line may be drastically different. And so the research should progress in those direction to see that the treatment technology which we design, which we suggest, should last for a longer time and it should be able to treat such type of emergent contaminants which may come up in the future. Now we'll come towards the a typical class of these PPCPs. So I will bring you to concentrate on a typical class of these pharmaceutical compounds. So most of these pharmaceutical compounds are prepared using pyridine. There are certain intermediates, there are certain raw ingredients. So this pyridine is the compound which is used to prepare many pharmaceutical compounds. And so if we focus on this pyridine, because India, after China, India is one of the largest manufacturer of this pyridine drug, and it also exports such type of drugs. So we never know that our wastewater bodies, our water bodies may contain this pyridine. And even the concentrations of this pyridine drug has been detected in the water bodies ranging from 20 to 300 milligram per liter. So we'll focus up about the issue. Since the biological treatment, one thing we know, the biological treatment is getting more less efficient when we deal with such type of compounds. So a chemical pre-treatment. So if we can provide a chemical treatment before the biological treatment, then can we solve this problem? A chemical treatment, what is the necessity of a chemical treatment? This chemical treatment can be anything. Here I'm discussing about this advance, but there are many other options of chemical treatments which can be studied further. So the role of a chemical pre-treatment is only to increase the biodegradability. Once the biodegradability is increased, then the biological treatment will be effective. If we focus only on the biological treatment of such compounds, then even this research have shown that it may be possible if we can use some cultures of these microbes for biological treatment. But it takes a very long time, around 20 to 30 days. So that again depend upon the type of the compound. Uh, but this time period is very long. It's very difficult. Even mixture, because in the laboratory we talk about one compound, we study about one compound, but actually in practice it's a mixture. A wastewater body is a mixture of various compounds. So it's very difficult. And if a mixture of such pharmaceutical compounds is present in the wastewater body, and that wastewater is sent for biological treatment, then the laboratory studies have shown that even this biodegradation period may take various months, which is practically not possible for a good method, a good technique to suggest it. And that's why they are suggesting us to go for pre-treatment. It is just like how a mother feeds a baby, because the baby is not able to initially to chew the food, so she uses a mixer to make that food amenable for proper digestion of the baby. So a chemical pretreatment, the role of chemical pretreatment is to make the wastewater amenable for biological treatment, because there are many complex constituents. So this chemical pretreatment may break down these complex constituents, and it will convert these complex constituents into a simpler compounds. And once these simpler compounds are formed, then it will be easy for these microorganisms to deal with. And then only the biological systems will function. Now, why to go for the advanced oxidation processes? So I am switching over towards the advanced oxidation processes. Initially, I have talked about this chemical treatment. There are many chemical treatment methods. So this advanced oxidation is also a chemical treatment method. It is a broad term. Generally, if you see about the chemistry of this advanced oxidation process, you will find that it is about the formation of radicals, hydroxyl radicals. And these hydroxyl radicals will break down the compounds. And once the compounds are broken down, then it becomes easy. The mineralization becomes easy. So the BOD as well as the COD value will be drastically reduced, because the ultimate goal is to have a proper mineralization. Now, we are talking about oxidation. Even our biological treatment is an oxidation treatment, because the microorganisms oxidize the organic matter using oxygen. So there is a oxidation taking place. Here in the advanced oxidation, we are using such compounds which have high oxidation potential. And as you see from the table, the hydroxyl radicals are second after fluoride. Generally, fluorides are not used because of other issues. So hydroxyl radical is preferred and it has a potential. You check with the other oxidation potentials of the compounds. Fluorine, it has 1.36. Hydrogen peroxide, 1.78. And hydroxyl radicals, 2.8. So hydroxyl radical will have a more effect and it will also save the time because using a biological treatment alone is difficult, and if it is taking several days for the reduction of these compounds, then it is very necessary that this chemical pretreatment in the form of advanced oxidation using these hydroxyl radicals will reduce the time also, and it will also make the waste amenable to biology. Yes. So just a summary about the AOPs, advanced oxidation processes. So this is the family. There are many options available, lot of research scope available about these AOPs, homogeneous, heterogeneous, using energy, without using energy. Yes, ultraviolet radiations, ultrasound energy, using electrical energy. Without energy, there can be ozone, the alkaline medium, or a combination of ozone and hydrogen peroxide, combination of hydrogen peroxide and other catalysts. To talk about using energy, ultraviolet radiations, ultrasound energy. So wide scope about the combination of two or three can be tried to study the effect on the compounds. So ultimate objective is to remove such compounds, such emergent compounds. So if one is interested about this use of AOPs, then a wide scope is available, the research of these compounds. The literature also reports various studies about this. Each has its own merits and demerits. Now, in my today's talk, I will focus about the Fenton process. So it's not something a very new technology. Most of you must be aware of this technique and why this Fenton is helpful. What makes it as a suitable pre-treatment option is that it uses a Fe2 ion and a hydrogen peroxide. So it's a mixture which can be very easily created in the laboratory. So the source of Fe2 can be a ferrous sulfate, which is also easily available in the lab, and a hydrogen peroxide that is also easily available. If you can mix these two, the hydroxyl radicals are great. And it's a chain reaction. It's a chain reaction, it's a fast reaction, and it continues. So these hydroxyl radicals will decompose the compounds. So I will not go in much chemistry part here because just I want to throw a light about the role of one of the AOP in treating the compounds. So in addition to these hydroxyl radicals, there are hydroperoxide radicals also generated. The ferrous ion can also react with any excess hydrogen peroxide. So it's a experimentation. Ultimately, as a research, if you want to do any research related to this, it requires much experimentation about the dosing of these compounds. So I will show you a case study in the coming slides where I have tried to optimize these doses, and I will also share you the results. One thing to be noted here is that we have to be very cautious about the reaction, because the excess dosing may also create a reverse effect. But ultimately, this Fenton reagent has proven to destroy a wide variety of the compounds. And for these pharmaceutical and personal care compounds, it is one of the viable technique. But one thing to be remembered is about the intermediate oxidation products. In any chemical treatment, I'm not talking only about this penton now. It may be any chemical pre-treatment, and we have to see about the possibility of intermediate compounds. I am using a chemical to destroy a pollutant. It may happen that the pollutant, while or undergoing destruction, may get converted into some other form which cannot be detected by equipment or any other tool. And it may also happen that the byproduct which is generated during this oxidation, chemical oxidation process, may also have a reverse effect, or it may be more toxic, may be more hazardous, may be more carcinogenic than the parent drug also. So this is one precaution to be taken while going for such type of technology. So choosing proper hydrogen peroxide dose, using proper ferrous sulfate dose is very necessary, because any excess dose may also have a reverse effect. The another option or another method about this AOP is a photophantom. Very similar to the phantom, only addition is that the phantom process is in the presence of the UV light, and this has shown to be more effective. Photophantom is considered to be more effective than the phantom because you have added one additional element, that is the UV light. With the help of UV light, the process will speed up, and so whatever intermediate compounds which are generated, whatever byproducts which are generated, that will also be destroyed. Now I will discuss about a typical case study. Certain compounds were selected of pyridine origin, a class of compounds. As you can see in front of you the slide, the class of aminopyridine compounds, their structure. Now this is the 2 aminopyridine ring or 3 aminopyridine ring or 4 aminopyridine ring, which is used for production of various drugs, many antihistamines, anti-inflammatory drugs. Various class of drugs are manufactured using these pyridine compounds. Even plant growth regulator or uh, any dyes which are used for hair dyes also, they are also manufactured using such class of compounds. One more important point to be noted, when the patients which are undergoing treatment for Alzheimer's disease, the type of drug, there are various class of drugs and most of these are manufactured using this pyridine. So it's a pyridine class. There is a possibility that in the future, the wastewater, the water bodies will have more concentration of such pharmaceutical pollutants. So we have to give special attention towards the removal of such type of drugs. Another class is about this fluoropyridine, bromopyridine, and cyanopyridine. Okay. So various personal care products, various depending living standard of the people is increasing, and people are switching over towards various other say different types of shampoos, different types of hair dyes, or many skin treatments where various use of these uh, chemicals, lotions have been practiced. But once such elements enter into the wastewater body, then the role of environmental engineer comes into picture. And then we, as an environmental engineer, should focus about how to deal with such compounds. Even many cosmetics, many anti-malaria drugs, antiretroviral drugs. So most of there are thousands of drugs with options available for the medical practitioners. But after treatment of the patient, the post effect is observed in the environment. So what I want to say here as being an environmental engineer is that the role of the doctor may end up to the treatment of the patient, but the role of environmental engineer starts from there because the excreta, the urine, and other uh, chemicals and other liquids may contain these drugs, and this should not affect the environment. So there should be a proper treatment for the water body, for the environment also. Now, how to detect these drugs? So there are wide range of equipments available. The simplest technique is using a UV visible spectrum. No doubt, even HPLC, high performance techniques are also available. Uh, various advanced techniques are available. Various equipments are available which will detect the concentration. The simplest is the UV visible spectrum. Most of the drugs they can be detected, and from that we can find out the degradation. So since it is a chemical process, the role here of the during the study is to optimize the different parameters because we have to control the pH of the treated water. We have to see that any hydrogen peroxide, any chemical, because that is also having a good oxidation potential. The iron concentration which you are using, should also be optimized. So accordingly, in this case study, the optimization of these different parameters was studied. So it has been found out that the pH of the solution must be in the acidic range. Must be in the acidic range. Generally around 3. If you are able to control the pH around 3, then it becomes a good environment for the chemicals to function properly. Now, to be more precise, I have included this table so that each and every drug is to be separately studied for its removal. So the concentration of each and every drug, the dosing, the iron concentration, the hydrogen peroxide concentration, the degradation of the drug, and the COD. As I was telling you in the initial discussion, that only focusing only on COD removal is not going to help you. We have to also check about the individual concentration of the compound, and our target must be to completely degrade the parent compound. So accordingly, these oxidation studies were practiced. Similar for photophantom, and as you can see here, the photophantom oxidation studies, they have shown 100% degradation for these class of compounds, the amino compounds, but not for the other class because they are more resistant. So likewise, there are thousands of compounds which may behave differently. So whatever treatment we are suggesting, it may also be inefficient in removing some class of compounds. But as a majority, we have to see that the type of treatment which is practiced in the sewage treatment plants must be able to remove majority of the compounds, or at least destroy the effect, or at least fragmentize the compounds into simpler forms so that the remaining part or the remaining role can be taken wisely by the biology. So likewise, the dosing combination was done. Mineralization of the drugs is also studied, and optimization. So the concentration of this ferrous hydrogen peroxide was increased suitably, and it has been seen that it depends upon the concentration of the drug also, the pH of the environment. So one has to be very cautious about the pH and about the concentration of this iron and hydrogen peroxide. So this is the range of compounds, and the reaction time is also observed. The time period in minutes required to completely degrade these compounds. So if you are using the biological treatment alone, which may take several days, but with a suitable advanced treatment, advanced oxidation process, in minutes and hours, the drug will be totally destroyed. So separately, the dosing of hydrogen peroxide in stages. Now, sky is the limit for this. Whether you can add the hydrogen peroxide all at once, or you can add in stages, can be studied separately. But it has been observed that it is better to add this hydrogen peroxide doses in this way, because this hydrogen peroxide will ultimately scavenge the radicals and will reduce the rate of reaction. So dosing of hydrogen peroxide is very important. The timing is also very important. It's, I can give an example where a doctor, how he prescribes, how in the prescription he writes the name of the drug, and he tells that you can take one pill in the morning, one in the afternoon, one in the evening. There should be a time lag of say at least 6 hours or 4 hours. Okay, so he knows more better about the timing. Similarly, as an engineer, environmental engineering, if you are prescribing a treatment for removal of the drug, the timing is also equally important. The dosing is also equally important. Okay, it's not that only the dose will make the change. It's also the time which will make the change. So proper dosing at proper time interval is going to make the change, positive change. And that is what is to be found out from the research studies. So likewise, this time period and initially the first 30 minutes, what is the maximum degradation? Likewise, from depending upon the time period, percentage degradation can be studied separately. So one can go in more detail about the degradation studies also. But ultimately, our target is to get 100% degradation. So the rate takes, how much degradation takes place in the first 30 minutes, what is the rate? This can be done. You can compare the different methods. And this is the UV spectrum. So these peaks are, this is the before treatment and after treatment. You can see it's a completely flat peak. So this indicates that the drug is destroyed. Okay. We have to check it. Okay. So the samples were scanned before and after treatment, and they were compared. So this is also one of the option available to the UV spectrum, through which you can check whether your method, how far is more efficient. Now about the mixture of these drugs. So as I told you that these pharmaceuticals, they also coexist as a mixture in the water bodies, and it's a just like a chemical cocktail. It's a chemical cocktail. So the wastewater bodies surrounding us, which are a part of the city now, are nothing but a chemical cocktails. So a mixture study is also equally important, because a compound may also behave differently when it is in mixture with other compound. So separate studies of the mixture of these compounds is also equally important. So this is just a table to show the different absorptivity values, different wavelengths, and a mixture. So what will be the COD value of such compounds when it is in mixture? This is also equally important. Individually, the degradation may be different, the COD may be different. And one thing you can say that in a mixture, it's always difficult to deal with the compounds. And this is a practical case study. This is a practical case study. The time period is also equally important. So this chart will show how the degradation continues with the time period. So initially you can see the 6 color bands. These are the 6 different compounds in the study. And as time progresses, you'll see each and every compound is behaving differently. each and every compound is behaving differently. It is taking its own time to degrade. Okay. So such time study is also helpful to decide about what should be the detention time in the treatment process. And then with this available chart, with this available behavior of these compounds, then you can target this and you can try to optimize the dosing of the chemicals which you are using. And here you can see these are the different combinations which are tried. And then you will see increasing the dosing, increasing the time, and you will find that say 150 minute here you can see there is no chart. Initially you can see all the 6 drugs, and then as time progresses you will find the degradation. So you will find that these color bands will go out, and say now here 90 minutes only 4 compounds are present. Other 2 compounds are already degraded. Likewise, you continue till there is not a single drug present in the US code. And this is how you can practice the dosing to decide the time. Now here you will say, you will guarantee that after 150 minutes, if I use this combination of dose, then the compounds will be reduced. Similarly, the COD studies can also be carried out, the mineralization studies, and it's very difficult to achieve complete mineralization. Because it is not possible to achieve complete 100% COD removal. So various combinations are required. Likewise, different charts showing different compounds and their different time periods. So this was a study where the laterite ion was used. Likewise, different ion sources can be practiced. What is the intention here is to tell you about when a chemical method is necessary, but the chemicals which are used for the chemical treatment method must be studied for their optimum usage. These are the optimization of the reaction times, different photophenton, penton studies, the COD removal techniques, the mixture, the kinetic studies, and as I told you that UV spectrum is one technique, UV visible spectrometer. One can also go for this HPLC, high performance liquid chromatography, and such chromatogram of the compounds can also be checked. So this is a typical compound, two periodic compound. This is a chromatogram, and then 4 different techniques to remove this compound are tried. And after treatment, what is the chromatogram that is checked, and then one can decide whether the compound is removed or not. So finally, the degradation time, the dosing of the compound, the scavenging of the compound, the characteristics of the compound, the behavior of the compound in a mixture, all these parameters are to be separately studied before arriving at the conclusion. So just the last few lines which I want to tell you is that these emergent contaminants are destroying the environment, and as an environmental engineer, one cannot stick to the conventional treatment techniques. These conventional treatment techniques will no longer remain valid till for longer term. Some modifications of these conventional treatment technologies can be can work out, or a combination of advanced and conventional. So various practices are to be focused on to see that the wastewater bodies, the pure water bodies of the cities are free from these emergent contaminants. So I thank you all for patiently listening to the session. I thank the organizing team members. I thank Principal Dr. Burmani sir for giving me the opportunity, and all the participants who have joined here. Thank you all.
All
Thank you, sir.
right. All right. So thank you, sir, for sharing your valuable knowledge. Feedback link has been provided in the chat. Participants are requested to fill the feedback for this session. Now, if anyone has any question, we have the slot open. So please do put the questions. We'll wait for next 5 to 10 minutes.
Hello, Natraj sir, are you there?
Hello.
Good
Hello.
morning, sir. Good morning, sir, and
Good
welcome
morning,
you.
sir.
Welcome you in this program. Just now the session 4 is
Thanks a lot, sir.
yes, sir. If you have any doubt or queries, please free to ask. Please free to ask. Hi, sir.
Session 2 able to go through the next also.
Hello. Good morning, sir. Hello.
Good morning.
Hello.
Sir, I am Manivanan. Sir, I
Okay,
am
welcome
Manivanan
you,
from
sir. Welcome you, sir.
CWRS. Actually, sir,
Okay, welcome you, sir.
thank you, sir. You made all oxidation process by chemical methods.
Yes.
Could you try for any biological treatment for improving oxidation process?
Yeah, that is what I am going to tell you, that this chemical will be best suited as a pre-treatment to biological treatment method.
Okay.
That is what I want to tell you. Because
Acha.
only chemical and only biological alone may not turn up to be 100% efficient.
Okay, sir.
A combination can be a good alternative.
Yes, sir. Okay, sir. Okay.
Okay.
Thank you. Thank you very much, sir.
Okay.
चार वरती बारकं इथे ठेवू हं? बंडू बंडू
So, thank you, Karai sir, for sparing your valuable time. Now we will have a short break and we will be resuming this program by sir 11:15, right?
Yes, yes. 11:15 is the
Yes.
reporting time for next
Yeah.
session.
So we'll be
Karan sir.
resuming this program by 11:15 p.m. All the
Okay, Karan.
participants are requested to stay connected
Okay.
for the next session.
Karan sir, good morning.
Good morning. Good
गुड
morning.
मॉर्निंग. माझा सकाळी आवाज येत नव्हता. मी तुम्हाला विश करत होतो पण ते अनम्यूट
Okay.
होतं माझं ते. हो हो हो
अच्छा,
हो.
अच्छा,
छान
अच्छा,
झालं
अच्छा,
प्रोग्राम.
अच्छा.
छान झालं. छान झालं.
Thank
युअर
you. Thank you.
प्रेझेंटेशन इज व्हेरी
Thank you.
नाईस नाऊ.
Thank
And
you. Thank
definitely
you.
it is helpful to all the participants.
Yes, yes, yes. Shall I leave now, sir? With your permission?
Ha, yes sir. Yes sir. Yes sir. Yes sir. No
Okay.
problem.
चला
Okay.
बाय
Thank
करायचं
you.
सर.
Okay. Okay. Thank you.
भेटू.
Thank you all.
येस येस थँक्यू थँक्यू. नगरे सर
हा बोला सर. पारकर सर बोला.
11:15
बोला
ना.
सर. हा 11:15ला. हो हो.
ओके ओके.
कारण कोल्हे सर जॉईन 11 वाजता होतील सेकंड स्पीकर.
बरं 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 चालेल चालेल. ओके
मग आपण थोडं ब्रेक मध्ये मग त्यांचं टेस्ट बी करू ना व्यवस्थित आवाज येतोय किंवा काय. हा
चालेल
ठीक आहे
चालेल
सर.
चालेल चालेल. ओके.
ओके सर. ओके सर.